This video is on the slope of a line. Here we have four types of slope. If it goes up left to right, it is a positive slope. If it goes down left to right, it is a negative slope. If it is flat left to right, it has a slope of 0. And if it is a vertical line, it is undefined. We'll talk more about why that's undefined later, and we'll also talk more about lines later. I want to show you a few more examples, and then we're going to pause from graphs and then come back to them later. I'm going to teach you a different way to do slope first, but I just feel like we need a general understanding of graphs first, and then we'll come back to the graphs later. So here's a line. It is going up left to right. It has a positive slope. What is that positive slope? Well, you can count from anywhere that this line goes right through the grid, such as the x-intercept of -2, and this point 1, 5, they've got dots, so I know it goes right through the grid on those points. So if I count how far I go up, 1, 2, 3, 4, 5, over how far I go to the right, 1, 2, 3, I have a slope of 5/3. If you'll notice, that's also the difference in the two y values, 5 and 0, and it's the difference in the two x values, 1 and -2. Here I have a negative slope, and I'm going down 7, and then I'm going to the right 5, so I have a slope of -7/5. We'll talk more about those numbers later. Here I have a 0 slope, and one more time on the straight up and down line, that would be an undefined slope. I've decided to teach about slope without graphs first, and then we'll go to graphs later. So the first thing we need to know is that the variable m is used as slope. For instance, here's my equation. It says m equals rise over run. M means slope. So slope equals rise over run. Rise is how far you go up or down, and run is how far you go left or right. Just remember, you rise up or down, and you run left or right. You can't run up or down, and you can't rise left or right. Rise is up or down, run is left or right. Rise over run is generally used when we're looking at graphs like the few examples I just showed you, and we'll get to those again later. What we're going to do right now is this equation, m, meaning slope, equals the difference in your y's over the difference in your x's. Slope is the difference in your y's over the difference in your x's. Remember, all coordinates are written x, y. So if I had these two coordinates, -3, 4 is one coordinate, 2, -3 is the other coordinate. If I put a dot on the coordinate plane for those two coordinates, and I counted rise over run, I could find the slope. But without putting them on a coordinate plane, we can also find the slope by using this formula, the difference in your y values over the difference in your x values. Your y's have to go on top, and your x's have to go on bottom, because your y-axis rises up and down, and your x-axis runs left and right. My y values have to go on top. It doesn't matter if I go left to right on top, 4 minus -3. It just matters that I'm consistent. So if I say 4 minus -3 on top, then I have to say -3 minus 2 on bottom. If I go left to right on the y values, which I did, then I have to go left to right on the x values. If I had went the other way on the y's, I could have went the other way on the x's. So once I have written the difference in my y's over the difference in my x's, it's just a matter of working it out. When you have minus, negative, or even minus signs, sometimes it's best to change subtraction to addition, sign of the next number, to make it look like this. Instead of having minus negative, I would change that to plus positive. And here, instead of having -3 and -2, some people may want to change it to -3 plus -2. Doesn't matter, they're all the same. I always change my minus negative to plus. If it's just a minus sign, I normally leave it. -3 and -2 is -5. and then you add them together. 4 plus 3 on top is 7. -3 plus -2 on bottom is -5, and that is your slope, -7/5. The negative sign can be on the bottom or the top, and the whole fraction is negative. If the negative sign were on the top and the bottom, then the whole fraction would be positive because a negative divided by negative is a positive. Let me zoom out here. So the first time I went left to right, I said 4 minus -3 over -3 minus 2, left to right. Here I went right to left. -3 minus 4 on top and 2 minus -3 on the bottom. Left to right, right to left, right to left. And notice I get the same answer. -3 and -4 is -7. 2 minus -3, which becomes plus +3, is +5. Either way, your slope is -7/5. So slope is rise over run when we're doing it on a graph, but when we're doing it with just two coordinates, it's the difference in your y's over the difference in your x's. Doesn't matter whether you go left to right or right to left, you just have to do it the same way on top as you do on the bottom. I'll do one more example for you here. I'm given two coordinates. I don't have to graph them on a coordinate plane. I can just do the difference in my y's over the difference in my x's if it asks me for slope. Now I could put m equals, but I don't even have to do that. I just know I'm going to subtract my two y values on top. I'm going to subtract my two x values on bottom. So I start with something that looks like this. I'm going to go left to right on my y's, 5 minus 0. I'm going to go left to right on my x's, 1 minus -2. A mistake some people make is they just put a 2 here because they already have a minus sign, but that minus sign was already there. We have to add -2. I'm going to change minus negative to plus positive, and then I'm going to work it out. 5 minus 0 on top is 5. 1 plus 2 is 3. Your slope is 5/3. I would rise 5, run 3, which we'll talk about later. But right now, that's all you need to do. Your slope is 5/3. Try 4a. On 4a, I can go left to right or right to left, but I notice if I say 6 minus 8, I'm going to get -2. 3 minus 4, I'm going to get -1. I'll do this one twice. If you did it that way, you would have gotten -2 over -1, which simplifies to +2 over +1, or just 2. I just instinctively kind of looked, and I know if I went right to left, I'd have positive numbers, which I like better. So if you went right to left, you have 8 minus 6 over 4 minus 3, which would give you your +2 over 1 to start with. Not a big deal. I just try to do what makes it positive if I can on both. If one of them is going to be negative, it really doesn't matter. Just whichever way is easier. Try 4b. On 4b, I'm going to go left to right. -2, -2 on the y's. -4, 0 on the x's. Change that to plus positive. -2 and +2 is 0. -4 minus 0 is -4. 0 divided by -4 is 0. So the answer to that one is 0. 0 slope. Try 4c. On 4c, I see I'm going to be dealing with negatives either way, so I'm just going to go left to right. 2 minus 10 on top for the y's, -4 minus -2 on bottom for the x's. I'm going to change that to plus positive. I'll change that to plus negative. 2 plus -10 is -8. -4 plus 2 is -2. Same sign, positive answer, and 8 divided by 2 is 4. So your answer is +4. Now, you could put 4 over 1, because when we graph these, we kind of need a denominator because we're going to rise 4, run 1. But if it just asks you to slope, the simplest way to say it is 4, not 4 over 1. So we should be writing 4. Try 4D. 4D, my y's, I'm going to go left to right. My x's, I'm going to go left to right. I'm going to change subtraction to addition, sign of the next number. On top, 7 minus 7 is 0. 6 plus 2 is 8. Your slope is 0. Try 4e. On 4e, I'll go left to right. 2 minus 4 on top, -2 minus -6 on bottom. I have a double negative, so I'm going to change it to a double positive. 2 plus -4, and you can change that to look like if you want. 2 plus -4 is -2. -2 plus 6 is +4. That simplifies to -1/2. Your slope is -1/2, which means, by the way, if you're on a coordinate plane, you would rise -1 and run +1, 2, and your slope of your line would be slanted like that. But we'll talk about graphs more later. Let's try 4f. And 4f, it doesn't matter, so I'll go left to right. 3 minus 11 on top, 4 minus -1 on bottom. Change minus negative to plus positive. 3 plus -11 is -8. 4 plus 1 is 5. -8/5 is your answer. Try 5a. Now I do notice on 5a, if I go right to left, I don't have any negative numbers. Not that it matters, but I just like that. So I'm gonna go 7 minus 3 on top, 6 minus 6 on bottom. That gives you 4 over 0. If you put 4 divided by 0 in your calculator, it will give you error because you can't do it. You can't divide by 0. So the answer to that one is undefined. And if we graphed it, if I rose 1, 2, 3, 4 and ran 0, I would just have a straight up and down line, undefined slope. Try 5b. 5b, I'll go left to right. 2 minus -1 on top, -3 minus -3 on bottom, plus positive, plus positive. 2 plus 1 is 3 on top. -3 plus 3 is 0. Again, I have an undefined slope. I hope these are really easy, but they're really important as well. So let's do 4 more. Try 6. On 6, I notice that if I go right to left, I have positive numbers. 9 minus 3 on top, 6 minus 5 on bottom. 9 minus 3 is 6. 6 minus 5 is 1. Your slope is 6. Try number 7. Number 7, I'll go left to right on the y's and left to right on the x's. I have a minus negative. I'll change to plus positive. 3 minus 1 is 2. -4 plus 2 is -2. So my slope simplifies to -1. Try number 8. I'm going to go right to left. 3 minus -2 on the y's, 8 minus 6 on the x's. Minus negative becomes plus positive. 3 plus 2 is 5. 8 minus 6 is 2. Your slope is 5 over 2. Last one, number 9. I'm going to go left to right. All right, left to right on the y's, left to right on the x's. Change your minus negative to plus positive. 10 minus 3 is 7. 1 plus 8 is 9. Your slope is 7/9. Now let's look at graphs. Now I could do the difference in my y's over the difference in my x's and find my slope. But in order to graph lines, you've got to be able to count the slope as rise over run. So it doesn't matter which one you start at. I normally go left to right. Matter of fact, I almost always go left to right. So if I start right here and I count my rise, I rise up 1, 2, 3, 4. Rise is 4 over. And I run 1, 2 over 2. 4 over 2 simplifies to 2. My slope is 2. And the difference in my y's was 4, and the difference in my x's was 2. Now, I have dots here and here that I counted between. But I could have counted between any point where it went right through the grid. It went right through the grid here, rise 1, 2, run 1. Right here, rise 1, 2, run 1. Rise 1, 2, run 1. Rise 2, run 1. And I could go on infinitely many times, rise and 2, run 1, because my slope is 2. On number 2. If I count between the dots, I rise 1 box. And I run 1, 2, 3. Rise 1, run 3. Your slope is 1/3, which is also the difference in your y's over the difference in your x's. Now, if I kept going, rise 1, run 1, 2, 3, I'm right on that grid again. Now, I know instantly on number 3, I'm going to have a negative slope because my line is going down left to right. I'll just use the dots since they gave them to me. I rise down, so negative 1, 2, 3, rise negative 3 over, and then I run positive 1. And my slope is negative 3. There's another place that goes right through the grid right here, and I could have counted slope from there. Rise negative 1, 2, 3, run 1, right on the grid. Rise negative 1, 2, 3, run 1, right on the grid. Rise negative 1, 2, 3, run 1. If I had one more grid space, it'd be right on it right there. I'll give you some more examples. This one only has 1 dot, but it goes right through the grid right here. So I can count from here. I can count rise negative 1, 2, 3, run 1. Or, and I didn't do this on the other 3, but I could have counted right to left. So I could have started here and say rise 3, run negative 1. Rise negative 3, run 1. Rise positive 3, run negative 1. Either way, that simplifies to a slope of negative 3. And the slope is given right here. M equals negative 3. This one has a slope of 1. It says it. If you went between the intercepts, you would rise 3, run 3, or rise negative 3, run negative 3. But a slope of 1 is going to go through every single grid. So as soon as I see one that goes through every single grid, I know my slope is 1 if it's going up, or my slope is negative 1 if it's going down. And again, this one tells you it has a slope of 2, but let's look at it. Right through the grid here, right through the grid here. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. Rise 2, run 1. Or rise negative 2, run negative 1. Rise negative 2, run negative 1. Rise negative 2, run negative 1. Either way, it simplifies to a slope of 2. I'm going to pause and let you try number 10. Try to find the slope of that line, number 10. This one goes through every single grid downward. Rise negative 1, run 1. Rise negative 1, run 1, all the way down. So I know my slope is negative 1. If you had have counted between the dots, you would have counted rise negative 5, run positive 5, which still would have simplified to negative 1. And instantly we knew it was negative because it went down. Try number 11. Instantly, I know number 11 is a positive slope. I would have counted between this dot and right here, but I could have used this spot, this spot, this spot, this spot, or this spot because it goes right through the grid that many times. And on all of them, you rise 2, run 1, rise 2, run 1, rise 2, run 1. If you had a counter between the dots, you rise 4, run 2, which simplifies to 2. And if you had counted backwards from right to left, you'd have gotten rise negative 4, run negative 2, which also simplifies to 2. So no matter how you count it, your slope is 2. Try number 12. On number 12, hopefully instantly you know it's negative, it's going down. Between the dots, you rise negative 4. 1, 2, 3, 4, run 1, 2. And that simplifies to a slope of -2. And I could have went right through the grid here, 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 every one, -2/1, every time you do it. We can't graph later if we can't do slope now, so I want to practice some more. Let's try number 10. Give me the slope. Between the dots, you rise to, run to. But you could have counted between any of the grid. It goes through every single grid up, rise 1, run 1. Your slope is 1. Try number 11. On number 11, it goes through every single grid in a downward slope. So my slope is -1. If you had counted between the dots, rise -4, run 4. If you counted between the x-intercept here and the y-intercept here, rise -5, run 5. All of those simplify to -1. Try number 12. If you count between the dots, you're rising -1, 2, 3, 4, and you run 1, 2. -4/2 simplifies to -2 because it also went through the grid here and here. -2/1, -2/1, -2/1. All right, let me try to teach you something else on the fly right here. I know just by looking at it that the equation for that line is y equals 2x plus 1. And hopefully by the end of this unit, you'll be able to do that. If I plugged in some numbers for x, such as, let's just start with 0 for x. I get 0 plus 1 is 1. If I plug in 1 for x, I get 2 plus 1 is 3. If I plug in 2 for x, I get 4 plus 1 is 5. If I plug in 3 for x, I get 6 plus 1 is 7. We need to be able to look at a table like this and find the slope. When we do that, it's the difference of the y's. Let's just choose two. Let's choose this one and this one. I have an xy and an xy, just like we did before. The difference in your y's, 3 minus 1 over the difference in your x's, 1 minus 0. You get 2/1. You have a slope of 2, which is true of our graph. Rise 2, run 1. Rise 2, run 1. Let's look at another one. All right, the equation for this line is y equals 1/3 x. It's probably not going to be a good one to do. Just to make the math easy, I'm going to go by multiples of 3. So if I plug 3 in for x, I get 1 for y. If I plug 6 in for x, I get 2 for y. If I plug 9 in for x, I get 3 for y. If I want to know the slope of this line, I can do the difference in my y values. It doesn't matter which ones you pick. This time I'll pick these two. The difference in my y's, 3 minus 2 over the difference in my x's, 9 minus 6. I get 1/3. My slope is 1/3. So my point is you need to be able to look at an XY table and do the difference in your y's over the difference in your x's. Let's use the top two. 2 minus 1 over 6 minus 3. I get 1/3. Let's use the first one and the third one. Let's try that. 3 minus 1 on top, 9 minus 3 on bottom. I get 2, 6, which simplifies to 1/3. So it doesn't matter which two coordinates you use. If you simplify it, your slope will always equal the same. In this case, your slope is 1/3. So what is slope? Slope is associated with the graph of a line. We need 2 points to draw a line. We talk about slope like of a roof. Some roofs are steeply sloped, some are shallow slope. If you're snow skiing, some is steeply going downhill, some you go down shallow and go slower. The 4 different types of slope is positive if you go up left to right, negative if you go down left to right, Zero slope because you rise 0, run whatever. Let's pretend you run 4. 0 over 4 simplifies to 0. You have 0 slope. This is an undefined slope. I rise whatever. Let's say I rise 4, but I run 0. 4 divided by 0, you can't do it. Cannot divide by 0, so a vertical line is undefined slope. Slope equation. Slope is the difference in your y's over the difference in your x's. It's also rise over run. How many points do we need to draw a line? 2. Video, video, video. These are all here if you want to watch them later. Here's an example of 0 slope. Here's an example of undefined slope. Ask yourself, could you ski on this slope? The answer is no. You would just fall down. That is an undefined slope. Could you ski on this slope? You could. It's flat. You'll just have to work a little harder. This is 0 slope. This is undefined slope. Video. Let me try to go through these. I'm looking for the slope of this line. It goes through the grid right here. And again, right here. So that is a rise of -1, 2, 3, run 1, 2, -3 over 2. This is a flat line. I rise 0, I run whatever. 0 divided by anything is 0. Have a positive slope. It goes through the grid here. Rise 1, 2, 3, 4, 5, 6, run 1. It looks like it goes through the grid here and here, which is a rise of 6, run 1. Okay, this is an up and down vertical line. You rise whatever, but you run 0. If your 0's on the bottom, can't do it. It's impossible in your calculator. This is undefined. And they're going to say no slope. I'd rather you say undefined. But multiple choice, I guess, could be no slope. I just like undefined a lot better. Let's find the slope of the line. We're only given the 2 points. We have to use the equation, difference in the y's over the x's. So on this one, my difference in my y's, 3 minus 1 is 2. Difference in my x's, 7 minus 5 is 2. I get 2 over 2, which simplifies to 1. And they went right to left and got -2 over -2. You still simplify to 1. 6 minus 1 is 5. 3 minus -2 is 5. This should be a slope of 1. Okay, I notice that my 2 x values are the same. If my x values are the same on the bottom, I don't even have to do the top. If my x values are the same on the bottom, I'm going to get 0 on the bottom, which is an undefined slope. Or they're going to say no slope. It is not a slope of 0. 0 slopes when you, let's see, 0 slopes when the difference in your y's is 0. Let's stick with undefined when your bottom number is 0 because your calculator will not do it. 10 divided by 0, error. Here, I notice my y values are the same. If your y values are the same, that means you're going to get 0 on top. And 0 divided by anything is 0. So I know the slope of this one is going to be 0. I don't even have to worry about the bottom. 0. 2 minus 1 on top. 2 minus 3 is -1 on bottom. 1 over -1 gives you a slope of -1. Okay, so we need to be able to do slope, difference in your y's over the difference in your x's like this by looking at a graph. Let's look at one. We need to be able to look at a graph and count rise -3, run 1. I know that's the slope of -3. And we also need to be able to look at a table that has coordinates in them and be able to do the difference in your y's, 1 minus -2, over the difference in your x's, 0 minus 1, plus positive, I get 3 over -1, which gives me -3. Need to be able to find the slope of tables, graphs, and coordinates. Thank you.